to take averages. All right. So the next question I had was, now that we've imported our data, how do we convert it into metric units? Okay. So let me do something here really quickly before we go any further. Let me actually define our variables here. We know that maximum temperature is in the first dimension of dummy 3. So I'm going to use something like this. Tmax equals squeeze. And squeeze is basically just trying to get rid of leading ones. Let me show you first if I don't do a squeeze. Tmax equals dummy 3, 1, comma, colon, colon, right? Because the first variable in dummy 3 is Tmax. So that should basically give us all of the data in Tmax. If you see, if I do a size on Tmax, I've got it's 1 by 12 by 106. MATLAB doesn't like leading ones. It's kind of just a waste of space. So we can just make it. We can just get rid of it by typing squeeze. This just gets rid of leading ones. So squeeze of Tmax. So now you can see that the size of Tmax is 12 by 106. Okay. So right now, again, I'll make a plot here of Tmax. This is January Tmax. If we want to, we can actually define year. We know that year went from 1906 to 2011. Probably a smart thing to do. So now we can make a plot of year Tmax, and it comes up looking something like this, right? So now we have our maximum average monthly maximum temperature for January. And again, we're looking at values here that are in degrees Fahrenheit. And these are not really units we want to use ultimately. So what we want to do is convert from degrees Fahrenheit to degrees Celsius. And this is a fairly simple task. Let's make a new variable, Tmax of C. Okay. And the formula to convert between degrees Fahrenheit and degrees Celsius is basically taking our temperature in degrees Fahrenheit, subtracting 32 from it, okay, and dividing the whole thing by 1.8. Okay, so we know again that 0 degrees Celsius is 32 degrees Fahrenheit. Okay, we also know that for every 1 degree Celsius, that equates to about a 1.8 degree change in degrees Fahrenheit. So let's do that. Okay, and if you like, again, I encourage you to continue checking the size of your data sets just to be sure that they are as what you would expect. Okay, and then we can make a plot of year versus the maximum temperature in degrees Celsius. And what we see now is a plot of what we actually want. So this is our temperature, maximum temperature in degrees Celsius for the period of record. Now, what to do with missing data? You can see that there is a significant amount of missing data in this particular data set itself, and this is why I encourage you to try to find data sets that did not have missing data. We can see, for example, here that we have some missing data in January, particularly, I think it might just be for 1 or 2 months in here. Okay, so we can see, we want to zoom in on this, we can see that sometime here in, it looks like 1974 and 1975, we did not have data for Kellogg. We can remedy this by actually going to WestMap. It helps if I type it in correctly. If we go to WestMap and we know the latitude, longitude of Kellogg, we can actually retrieve the data. We can get a good estimate of that data. Okay, so we're going to use the little map here and zoom in on Kellogg. I would suggest using the exact lat long from the metadata rather than my bootleg effort here, because I'm not sure, I don't know just off the top of my head where that station is in Kellogg, if it's in the city or if it's a mile or two out of the city, and that matters in the western United States where we have topography. I'm just going to assume it's downtown Kellogg. Okay, I'm going to click there and I'm going to extract, I need January temperature, so I can go here to maximum temperature for January, and I can just acquire that data. And what I really need to do is I need that data for 74 and 75. So I can go down here and I can find 74 and 75 and those again are temperatures in degrees Fahrenheit. So you basically have to take that data, okay, and plug it in, and then again convert to degrees Celsius. So it looks like 29.2, 32.4. I would get a data point somewhere down, around -1 something, and then something right around 0 for those 2 years to fill in that data set. Okay, so this is the end of this demo, and continue to send me questions, and I will hopefully provide answers to those questions.